Natural and man-made disasters often completely eradicate any and all food resources from affected areas. What if something like this were to happen on a global scale? Would we be prepared? Fortunately for humans, it is likely that we would be. Around the world, there are huge centres, often referred to as doomsday vaults, storing samples from almost every possible food source known to us. These are gene banks, research centres which work to find solutions to our food problems now and in the future. And there are more than 1,700 of these globally. One of these vaults lies on a remote island in the Arctic Circle, located in Norway's Svalbard archipelago. Here, at the Global Seed Vault on the island of Spitsbergen, are millions of minuscule seeds from more than 1 million varieties of food crops and more than 13,000 years of agricultural history. The building stores the world's largest collection of agricultural diversity in one place. This particular vault stores duplicates of seed samples from all of the crop collections internationally. The vault itself is located well above sea level and over 100 metres deep into the mountains, and is described as the ultimate insurance policy for the world's food supply. And the building is also surrounded by permafrost and thick rock to ensure that samples remain frozen at negative 18 degrees Celsius, even without power. While food production has increased dramatically over the past 50 years due to technological advances in agricultural practices, biodiversity has decreased to an all-time low. For example, only 10% of the rice varieties China used in the 1950s are still used today, and the US has lost more than 90% of its fruit and veg varieties since the 20th century. This monocultural approach to agriculture leaves food supplies more susceptible to disasters such as disease, drought, and famine. An example of a country currently suffering from food insecurity is Venezuela, which has been experiencing a crisis for close to a decade. There are many social, economic, and political reasons as to why this is happening, but the result of it is an extremely undernourished population, empty shelves in supermarkets, and spiralling inflation. Studies by several universities have estimated that around 80% of Venezuelan families are affected by food insecurity. Natural disasters are also grounds of food scarcity in communities. In April 2015, a 7.8 magnitude earthquake hit Nepal. This not only caused death, destruction, and disaster for the people, but left severe after effects, one of the most prominent being lack of food resources throughout the country. The earthquake resulted in the death of livestock and poultry, loss of more than half of stored crops of rice, wheat, and maize, and damage to the supplies of fertilizer and small-scale farming grounds, all of which placed families at a high risk of food insecurity and inadequate nutrition for the many months to follow. Fortunately, the Food and Agriculture Organization of the UN distributed bags of rice, grain, and vegetable seeds to be planted before the monsoon season, and many other emergency response organizations contributed similarly. Current events like these clearly emphasize the importance of food storage, security, and advanced planning in order to prevent natural and man-made disasters from affecting people in a similar way. The Consultative Group on International Agricultural Research, shortened as CGIAR, is a global partnership uniting organizations across the world for a more food-secure future. They have 11 gene banks located in centres, ensuring germplasm, which is the living tissue from which new plants can be grown, is acquired and distributed globally. Altogether, they hold around 750,000 samples of crop diversity. These samples are then distributed to researchers, scientists, farmers, and NGOs. The CGIAR collaborates with places such as the International Potato Center in Lima, Peru, which are vital to sustain the world's food storage and production. They collect and reserve the genetic material of potatoes in the event that all traces of it were wiped out due to a man-made or natural disaster. Preserving the genetic material allows for the production of these foods to become resistant to some of the effects of climate change, such as extreme heat and drought. Even just a couple of degrees too hot or cold can drastically affect a crop's growth, causing food shortage to become a real danger. There are 4,000 different varieties of potato, most of which can be found in the Andes, making Peru an ideal location for a research centre such as this one. The International Potato Centre has the genetic material for the vast majority of these species. Potatoes are the third most important crop for human consumption after rice and wheat. The total global production of the potato crop exceeds 300 million metric tons, and it is critical for food security in the face of the population growth we are currently seeing and will continue to see. In fact, China, the world's largest potato consumer, expects that 50% of the total increase in food production required to meet global demands will come from just potatoes alone. However, potatoes can be used for much more than just eating. Many countries in Eastern Europe, as well as Scandinavia, heat crushed potatoes and then use the starch to produce fermentable sugars, which can be used in the distillation of alcohol. The potato starch is also used for pharmaceutical and textile purposes. It's 100% biodegradable and can be used as a substitute for things such as polystyrene. Potato peel and other waste products are also rich in starch, which can be liquefied and then fermented to produce ethanol. At a potato-growing province in Canada, they estimated that 44,000 tons of potato processing waste can be made up into 5 million litres of ethanol. The headquarters for the Alliance of Biodiversity International and the International Centre for Tropical Agriculture is located in Italy. Here, researchers work with people across South America, the Caribbean, Asia and Africa to research tropical crops, particularly the banana. Bananas are known to be one of the most ancient fruit crops. It originated in Southeast Asia and the Pacific region, and for more than 7,000 years has been domesticated, which is the process in which wild species are artificially selected to evolve into crop plants, predominantly for human consumption. Approximately 150 million tons of banana are harvested annually, but only 15% of that is exported internationally. Typically, bananas are grown for home consumption, but the cooking varieties of the crop, such as plantain, are incredibly important for food security. There are 50 species of wild banana known to exist, but only 2 of those have been domesticated. The Biodiversity International MUSA, which is the scientific name for banana species, Germplasm Transit Centre is located in Belgium and houses the largest collection of banana germplasm anywhere in the world. Its aim is to conserve the genetic material of all known species of banana to secure the crop for future generations. They have a collection of more than 1,500 plant materials of both wild and edible banana species. These are kept in vitro under slow growth conditions at 16 degrees Celsius. Edible bananas are usually seedless, therefore the options of conservation methods are slightly limited. Typically, germplasm can be conserved in the form of DNA samples, or the pollen can be cryopreserved instead. This process is carried out by freezing samples at negative 196 degrees Celsius, the temperature of liquid nitrogen, allowing for the material to be preserved indefinitely, and revived into banana plants whenever it is needed. To ensure complete food safety, this cryopreserved collection is duplicated at another institute in Montpellier, southern France. Germplasm is not only kept in the case of a wild-scale food scarcity disaster in the future, but it can also be distributed to areas struggling with natural or man-made conditions, currently making them unable to grow required crops. Between 1985 and 2014, more than 17,000 of banana samples were distributed to banana-growing regions in Africa, the Americas, Asia, and the Pacific region, as well as extra samples going to universities and research centres in Europe. CGIAR has 14 more non-profit research centres around the world, each one specialising in specific crops and work into food security globally. The Africa Rice Centre is located in the Ivory Coast. The International Maize and Wheat Improvement Centre is based in Mexico. Centres in Kenya and Ethiopia host the International Livestock Research Institute. The International Rice Research Institute has its headquarters in the Philippines. The International Water Management Institute is located in Colombo, Sri Lanka, and World Fish is based in Malaysia. As well as these centres specialising in specific foods, there are institutes based in Indonesia, Lebanon, India and Nigeria, which research agriculture in different climate conditions, such as tropical and semi-arid areas. The International Food Policy Research Institute in Washington, D.C. provides policy-based solutions to reduce poverty, hunger and food scarcity, and aims to build a climate-resilient and sustainable supply of food worldwide. Advances in science are vital for the protection of our food resources. Without them, who knows how communities and nations could recover from potential disasters worldwide. If you are interested in learning more about food reserves and about doomsday vaults, I have linked articles and sources below in the episode notes which you can read. What are your thoughts on a more food-secure future? I would love to hear your opinions and your feedback.